Okay, question 12. We have a battery with an EMF of 12 volts and negligible internal resistance connected to a resistor network as shown in the diagram. And what we want to do for part A is calculate the total resistance. So we've got a parallel section over here in series with 50 ohms. First find the total resistance here, which is 1 over 40 plus 1 over 20 plus 1 over 40, and that'll be 1 over the total resistance in parallel, and that ends up as 4 over 40, and we flip that to get the total resistance, 40 over 4, and that's 10 ohms. So this section here, these three resistors overall provide a total resistance of 10 ohms. Now that is in series with the 50 ohms, so we add that on to the resistance, and that is 10 plus 50 and 60 ohms is the total resistance in the circuit. So it was 1 mark for this, 1 mark for that, and 1 mark for that. So that was the way you get your 3 marks. It says the second part, calculate the current through the 50 ohm resistor. Now 12 volts is supplied to all of the circuit. Some of that 12 volts goes to the 50 ohms. Some of that 12 volts goes to this section here, which is overall 10 ohms. So not all of that 12 volts goes to the 50 ohms. So if I want to find the current through the 50 ohm resistor, that will be the same as the current through the battery because it's in series with the battery. So if I use 12 volts, I must use the overall resistance in the circuit. So it will be 12 volts divided by 60, and that will be the current through the battery, which is 0.2 amps. That 0.2 amps will go through the 50 ohm resistor, and then of course that will split accordingly to the as in each branch according to the resistances, and then join back up to 0.2 amps here. But that is what the question asks. 50 ohm resistor, what is the current? So if you put 50 here, the voltage that should be here is 10 volts because you could do a potential divider and the ratio of the resistances. So 10 volts goes there, 2 volts goes there, and if you did it that way, it would have worked as well. However, it's 12 volts total voltage in the circuit divided by the total resistance is the current.